Okay, so we're first going to bootstrap the language we just used for complex numbers to fields, and then we're going to prove that the set of all rational expressions or rational functions over K is what's called a simple transcendental extension. But first, let's bootstrap our language. So suppose we have a simple extension. By the previous video, alpha is either going to be algebraic or transcendental over K. So we say the extension is algebraic. It is an algebraic extension, a simple algebraic extension, I should say. Simple algebraic extension. If alpha is algebraic over K, and it is a simple transcendental extension if otherwise. What is otherwise? Well, it's transcendental over K. All right, so we just bootstrap the language from before to field extensions. That's all that's happened. Let's prove a theorem. A set of rational functions over K which is K join T, is a simple transcendental extension of K. In fact, more is true. This is something that we've seen before in chapter 1, all simple transcendental extensions of K are isomorphic to this one. So not only is it a simple transcendental extension, up to isomorphism, it's the only one. There's no others. All right, proof. Well, it's clearly simple because we take a field and we add in just one thing, an indeterminate t. Okay, there's nothing going on there. Simple and generated by t. Suppose p of y is a polynomial. I'm using y to distinguish that the polynomial variable is different from the variable that we're adding in. There's a polynomial over k such that when you plug in t, you get 0. But t is also just another variable. This is just change the variable y to t. How could it happen that when you took a polynomial with a variable y and you change the variable to t, you get 0? Well, that only happens if the original polynomial was 0. So the only polynomial equation that t satisfies over k is the 0 polynomial. So t is transcendental over k. Now, intuitively, this should make sense. T is not even a number, right? It's a variable. How could it satisfy some equation over k? It shouldn't be able to, right? Because you're throwing in just some indeterminate. All right. So theorem. I guess I should have said here, not set, but field. The field of rational functions over k in the indeterminate t is a simple transcendental extension, and we'll shortly prove that all simple transcendental extensions of k are of this form.